Good morning, students. Now we will continue our session, which was the real number problems. Okay, so our next problem is prove that under root 3 is an irrational number. Prove that under root 3 is a irrational number. So we will assume that under root 3 is a rational number. Okay, then there exists a positive integer a and b such that under root 3 is equal to a by b. Why? Under root 3 is equal to a by b. Why? Because we have considered that under root 3 is a rational number, and if a rational number is being under root 3, then we can it represent it such that a by b. A by b. Why? Because a is an integer and b is also a integer. This is the natural form of p by q. Okay, so you can take a by b, and you can take also p by q. Okay, this is your choice. Then we should address that a by b is a is a is a p by q form, and a and b are the co-primes, and their HCF is 1. Okay, and their HCF is 1. HCF is 1 means there is no common factor between a and b. We are saying that there is no common factor, no common factor, no common factor between a and b. Okay, so now we can say that under root 3 is equal to a by b, and we will square both side. Okay, we will square both side, this side and also this side. Okay, if we square both side, then we will get 3. Then we will get 3 on the RHS, and a square by b square on the RHS, and 3 on the LHS. Okay, so b square will multiply by 3, and the equation will become 3b square is equal to a square. Okay, then what was our theorem? That if a prime number is a factor of a square, if a prime number is a factor of a square, then it is also a factor of a. Then this is the also a factor of a. Okay, this is the also the factor of. So we can say that 3 divides a square, then it is also proves that 3 divides a. Okay, by the theorem. Okay, next, if 3 divides a, then we can say that we can write a in such a form: a is equal to 3 into something, 3 into something. Okay, and something, we can say it is a c. We can say it is a c. Okay, then we can say a is equal to 3c. We can say a is equal to 3c. Okay, now if a is equal to 3c, then we will square both sides. Okay, then a becomes a square and 3c becomes 9c squares. Okay, and a is equal to 3b square also. Okay, a is equal to 3b square also. Then we can say a is equal to 3b square. Then we can put the value of a square in this equation by the given above. Okay, so a square is equal to 3b square is equal to 9c square. Okay, so we can say b square is equal to 3c square. Why? because 3b square is equal to 9c square, then b square is equal to 9c square upon 3. Okay, then 3 will cut 9 3 times. Okay, so that's why we can say that b square is equal to 3c square. Now according to the theorem, we can say that we can see that 3 divides b square. Okay, why? Because 3 is a factor of b square. We are getting b square by multiplying 3 and c square. We are getting b square by multiplying by 3 and c square. Okay, so we can say that c3 divides b square, that 3 divides b square. Okay, now according to the theorem, we can say that 3 divides b also. Okay, 3 divides b also. Okay, then according to the equation 1 and 2, we observe that a and b have at least 3 as a common factor. Why? Because here we can see 3 divides b and 3 divides a also. Okay, so a and b were the co-primes, but this is the contradiction. Why? Because we can see that, or we observe that a and b have at least 3 as a common factor. 3 as a common factor. But this contradicts the fact that a and b are co-primes. This means that our assumption was not correct. And what was our assumption? Our assumption was the under root 3 is a rational number. So that is wrong. Okay. So under root 3 is a irrational number. Under root 3 is a irrational number. So we conclude that under root 3 is a irrational number. Okay. Okay. Heading to the next question. It is saying that show that 4 plus 3 under root 2 is an irrational number. Okay. So we will assume that 4 plus 3 under root 2 is a rational number. Okay, then 4 plus 3 under root 2 and 4 are rational number also. Okay, this is a rational number and this is a rational number. Okay, if we add or subtract them, the quality of a rational number says that 4 plus 3 under root 2 minus 4 will also be a rational number, because rational rational numbers because rational numbers show the closure property in the subtraction manners. Okay, what is the closure property? Closure property says that if a is a rational number and b is also a rational number, then the result will be c, and this is also a rational number. Okay, so here we can see if we subtract 4 plus 3 under root 2 minus 4, then we see 3 under root 2, and the result will be rational. Okay, because the difference of the two rational numbers is a rational number. This is a closure property. Okay, then we have obtained 3 under root 2. Okay, now if we divide this by 3, or we can say multiplied by 1 upon 3. Okay, then we have also seen that if we multiply two rational numbers each other, then the resultant number will also be a rational number. This is a closure property in respect to the multiplication. Okay, so under root 2 is a rational number. Okay, because under root 2 is a result. Okay, 3 under root 2 multiplied by 1 by 3, 3 से 3 कट हो गया. Okay, so result is under root 2. Okay, the result will be rational, but we have seen that under root 2 is a irrational number, so this is the contradiction. Okay, so we can say that this contradicts the fact that under root 2 is irrational when 2 is prime. Okay, so under root 2 is a irrational number. Okay, and our assumption was wrong. What was our assumption? Our assumption was 4 plus 3 under root 2 is a rational number. Then this is wrong. Then what is this? 3 plus under root 2 is a rational number. Okay. If you have any query about two questions, then you can ask me, and I will solve that. Okay. So thank you, class.